Hi, my name is Ji Kim and I'll introduce the syngas production from greenhouse gas process. First, I'll introduce how I will discuss about this one. First topic is the greenhouse gas emission, and second one is methane to syngas, third one is chemical looping, and fourth one is the chemical looping from dry forming of methane process. First, I'll introduce about how the greenhouse gas emission is important and why you should reduce this gas. Greenhouse gas emissions include carbon dioxide, methane, and nitrous oxide from all sources, including agriculture and land use change. And as shown in the left graph, the greenhouse gas emission has increased rapidly from 1850 to 2021. And also from the right side, carbon dioxide is consisted of 74.4% of greenhouse gas, and secondly, the methane is consisted of 17.3%. Therefore, I will focus on these two gases, carbon dioxide and methane, and I will discuss how we can reduce this gas into other useful gases. Many researchers have tried to reduce the greenhouse gas and found the process of methane to syngas. And I'll discuss about these three processes. First is the dry forming of methane. Second one is the steam deforming of methane. And third one is the partial oxidation of methane. And from the syngas produced in this process, and by using the catalyst, the ChemE, methanol, hydrocarbons, aromatic polymers, hydrogen, such as these useful materials can be produced. Also, I want to focus on one of these reactions. This is the dry forming of methane, which reacts the methane and carbon dioxide to produce carbon monoxide and hydrogen. And for this process, the temperature is very high because the enthalpy is very high and needs high temperature to run the reaction. Also, the side reaction also occurs, such as reverse water gas shift reaction, which is the reaction that occurs from carbon dioxide and hydrogen to produce carbon monoxide and water. I'll introduce how the chemical looping is going and how we are going to use this one for the process. Chemical looping is a process that involves the reaction and regeneration of chemical intermediates such as metal oxide that can oxidize feedstocks. First, I will introduce the chemical looping combustion as an example. First, the steam and carbon dioxide react in solid fuel to produce steam and carbon dioxide. During the process, the oxygen carrier, the catalyst is reduced. Also, in the next process, the air is flowed, and during the process, the carbon oxygen carrier, the catalyst is once again oxidized, and we can use this catalyst again. Therefore, by doing this process again, we can use the same catalyst as for many cycles of process as we want. And also, I tell you about the research field I am currently investigating, the chemical looping dry forming of methane. And I have already introduced dry reforming of methane, which is a reaction from carbon dioxide and methane to turn into carbon monoxide and hydrogen. And by dividing this process into two portions, first is the catalytic decomposition of methane, and second one is the CO2 reduction process, which is a reverse Buddha reaction. First is the carbon catalytic decomposition of methane. The methane is decomposed in the very high temperature, and the hydrogen is produced, and the remaining carbon is attached to the catalyst surface. And next to the CO2 reduction process, the carbon on the catalyst surface reacts with carbon dioxide to produce carbon monoxide and regenerated catalyst. And you can do many several times as you want, and we can use this catalyst by preventing carbon cork production. And this is the end of my presentation, and thank you for listening.